Okay, ladies and gentlemen, so today we're going to be looking at is how we can take what we know about our rigid motions and what we know about dilations and try to get a more formal definition for what it means to be similar using those things. So similarity is defined as a mapping, right? So we're going to be putting one onto the other, where we do a dilation followed by a congruence, which is one of our rigid motions, whether it is a rotation, reflection, or translation. All right, so let's take a look here. In the picture below, we have triangle DEF, which is right here. So here's our original triangle, DEF. It's been dilated by a scale factor of k equals 4. It is noted by D prime, E prime, F prime. So that's right here. So we went this, we made it, dilated it by 4, now we're down here. Okay. Describe, which is, we also have triangle DE, D prime, E double prime, F double prime, this one. And we know it is congruent to this triangle. So I'm actually going to change these symbols. So we have our original, we have our first, and we have our second. And we know to get from, here was our pre to our image, and then to get from 1 to 2. I want to be able to go backwards. I want to know how can I get DEF, number 2, D double prime, E double prime, F double prime, back to our original. Well, in order to do that, I have to first take and move it over here. And if you look at the way the letters are matched up, they stay in the same order. So to get it from 2 to 1, I have to translate it. I could be specific because I'm translating 1, 2, 3, 4, 5, 6, 7, 8 left. And then 1, 2, 3, 4 down. Now I have to go from 1 back to the original. And to get back to the original, now I have to shrink it. So if it got bigger by a scale factor of 4, it's going to get smaller by taking and doing the reciprocal of that. So then I'm going to dilate by 1/4. So these two, my original and the number 2 and 3, are similar to each other. And the similar symbol is just the little squiggle. All right? 2 lines in a squiggle means that it's congruent. All right, let's try this one. Triangle ABC was dilated from center O by a scale factor of k. And again, I know these are hard to read. So here's our original, here's our pre-image, right? We did a scale factor of 1/2, and then that went to, I'm guessing that's going to be this one. So this is our first. Another triangle, A double prime, B double prime, C double prime, is congruent to this triangle. All right, so here's the 2. What scale factor would be used to dilate triangle A double prime to the same size as triangle ABC? So we have to do the reverse, right? Because I'm going from here, number 2, to the original. It has to get bigger, and it has to be the opposite of that. So it's going to have to be a scale factor of 2. Describe the sequence that would map triangle A double prime B onto triangle ABC. So the first thing we would have to do, right, is I have to move this back over to here. So I have to go translate it 1, 2, 3, 4, 5, 6, 7, 7 right. And we're going 1 down. And then dilate by 2. Oops. Okay, now let's see. What is the difference between this question and question number 1? Well, the difference is that in the other one we were shrinking, and in this one we're enlarging. All right, let's try another one. In the diagram below, ABC is similar, same size, different shapes, to A prime, B prime, C prime. Describe the sequence of a dilation followed by a congruence that would prove these figures to be similar. Well, I have to first figure out what the scale factor was used to get there. All right, so what do we want to do? Of a dilation followed by a congruence. Okay, so I have to first shrink it right? So to shrink it, if I look at this side and compare, I have 2, I have 1. So when I do my, oh my gosh, when I do my scale factor, sorry, it's always image 1 over pre-image. All right, so that means I'm going to dilate by 1/2. If I do that though, if I think about where that's going to put it, because I have my points here, I have, this is -2, 2. When I take half of that, it's going to be at -1, 1. And this would be, this is -2, 4, so this is going to be -1, 2. This was -8, 2, so it's going to be -4, 1. So right now, it's here. Right, so now I have to get it here. Well, how can I do that? Well, I can do, because I actually have to do 2 congruences, I have to slide it down and then reflect it. I don't know why it just didn't get reflected. I wish I could have reflected it first. Clearly, I'm thinking out loud to myself. All right, you know what? We're going to do that. We're going to just change this. We're going to flip it. We're going to do a congruence followed by a dilation. So dilate by 1/2, right? We know that that's what we're going to eventually have to do, but I'm going to reflect it first. So I'm going to reflect over the y-axis. And then dilate it by 1/2. All right, let's try one more. So now I want to go from ABC to DEF. All right, so we know ABC is similar to DEF. Describe a sequence of a dilation followed by a congruence that would prove that these figures are similar. Okay, well, here they give us our units. So I have to first figure out what my scale factor is going to be. So 6 over 18, which reduces down to 1/3. And to get from this first one to the second one, I believe I'm rotating it 90 degrees clockwise. All right, well, we'll try this one together in class tomorrow, but if you have any other questions, bring them with you and have a good night.